Okay, so this is me just going through every, at least one or two of each examples. So let's start off with page 256. And we're going to do numbers. So 256. And we're going to do numbers 28 to 35 on this one. So 28 to 35. 256. I don't know why I scrolled down though. 28 to 35. So let's do some of these, okay? So let's do number 28. Let's do 33 seems like a good one. Did I say to do 33? Or did I just say 35? Yeah. And then let's
There's also
do,
a page before that, but I don't know if you want to do that too. There's 255 also, right? What we have to do?
I don't know if any, did I ask for a question from 255 though?
255, I think you said to do, I could look it up, but that was evaluating logarithms without a calculator.
Okay, so the thing with logarithms or other calculator, you will have a calculator on this test.
Oh, the whole time we could have one?
So yeah, so you, because I can't really do a calculator, non-calculator section
Right.
on Zoom. So you're just gonna have a calculator there the whole time.
So are we starting from, are we gonna have to do like 20 through 27 also, or no?
20 to 27.
So
20
that's
to
just like
27 is
plugging it
definitely
in.
you want to practice that because that's using a calculator.
That's just like plugging it in, right?
Yeah, exactly.
Okay.
Okay. So let's do 28. So what happens here is 7 log 7. This number right here matches this number right here. And because those both numbers matches, you could cross them out. So all that's left is what's over here in the front. So that's x. So the answer for that one, when you have a log and an exponent matching, you could cross them out. Same thing here. This 5 matches, this 5 matches. You could cross these out, and we're left with x. So when they match, you could just cross them out, and that makes it easier. Remember, when you have a log and there's no number showing, that's a divisible 10. So if there's no number showing here, that's like a divisible 10 here. That crosses out, and you have 8. Now 32 to 35 is where there's an actual question. So it kind of refers to what we were doing right before we started recording. Is there a way I could rewrite 36 in order to match 6? So we're going to try to make this 36 smaller. So this 36, well, let's check. 6 to the 1 power is 6. Doesn't really help me. 6 to the 2 power is 36. Oh, wait a second. 6 to the 2 power is 36. So what does that allow me to do? Well, I can rewrite this thing right here, this 36, as this. So I'm going to rewrite the whole question as this. Log base 6, 6 to the second power, and then it's an exponent, right? X, like x is the exponent, so it's 2 times x. Okay? Now since they match, I could just cross out my logs. So a lot of these problems is first check, do they match? And if they do match, you could cross it off. And then what you're left with is 2x. 81. Well, that doesn't match with 3, but we try to find a way to make it match with 3. So we go to match it. Let's see. 3 to the second power. 3 to the 1 power is 3, so that doesn't make sense. 3 to the second power is 9. That doesn't work. 3 to the third power is 27. That doesn't work. 3 to the fourth power equals 81. And you can just check that with your calculator. You can always do this. Hey, that matches. So I'm going to rewrite this as log base 3, 3 to the fourth power times, so you multiply your exponents, so 4 times x is just 4x. Hey, these match now, and all you're left with is the 4x. Okay? And these two are the same thing. You're just changing the base. Okay? So you're just changing the base to make it match. That's the actual problem that's going on. So why don't we go to our next one, where we have this one, use with and without a calculator. So let's talk about without a calculator, because sometimes it's faster to do it without a calculator, and then we're going to talk about with a calculator. Okay, so without a calculator, you have to remember it looks something like this. Log base 15 equals x. So I'm going to rewrite this as log 15. Let's say I don't know it's 1, even though it says it's 1 here. Let's call it x. What I can do is take this 15 and slip it right underneath the x, and now it becomes, that x becomes an exponent. So I have 15 equals 15 to the x power. Now I have to ask myself, what to what power, 15 to what power gets me 15? Well, it doesn't change when you do it to the 1 power. So my answer in this one's 1. Here, I would do 7, and I would slip the 7 to the other side. So I have 49 equals 7 to the x power. What do I use for the x power? Oh, that's 2. So 7 to the second power equals 49. So my answer is 2. So you just have to think like what number would get you what you want. Okay? And then you can do that for all of this. Remember, a negative exponent move it down. So if you see a fraction like this, that's a big hint that you're going to get a negative answer. Or you see a fraction right here, that's a big hint you're going to get a negative fraction. But I have to be very honest, I'm probably not going to give you fraction ones, so don't sweat those. Focus more on the whole number ones. Okay? Then let's go to the calculator section. So the calculator section, and I think I'm going to open up my calculator actually. Let's see if I can do that. Nope. Where does it go? Now, here it is. So I'm going to open up my calculator. And the calculator section, there's literally a button on your calculator that has both log and ln. You might have to click second. No, I don't think you have to click second first, but you click that button and you just type in your numbers. So you click log and you press 14. It should be on the left, about 5 or 6 up on the left. And ln should be like 5 or 6 up. And both of those buttons will get you some numbers like that. So you just literally type into your calculator. I'm having a hard time pulling up. What's up?
I just want to tell you that I have to go, but thank you for the small review, and I'll watch the rest of the video later.
Okay, and I'll try to open up a lunch if you guys need help even tomorrow, okay?
Thank you so much. I really appreciate it.
No problem.
Have a great day. Bye, guys.
You too. All right, so let's keep going. The next thing on the checklist is find the inverse. Okay, so find the inverse, which some people have problems with, but that's fine. So the inverse, the step 1 of our inverse and finding an inverse. So I'm doing number 37 here. Log base 8x. Our first step of finding any inverse is you have to swap the x and the y position. So every x becomes a y and every y becomes an x. So x equals log 8y. From that point on, we don't want a base 8. Or we want y by itself, so we have to move this base log. So in order to move a log, just like before, we're going to make it into an exponent. So it's 8 to the x power equals y. Now, since y is by itself, our answer is complete and we're happy here. Let's try another one that's a little unique. Let's do 38. So 38, we're going to do y equals 7x. And after you get good at this, you just know you're going to have to replace it anyway. So we could just write it as x equals 7y. When you move a base of an exponent, it does the opposite when you change it. So it becomes base of a log. So it's log base 7, big X, normal size X, I should say, equals Y. And that matches what is over here. Again, if you put the Y in front and back, that doesn't matter.
Can you do 42?
Sure. So then 42, we have a couple of things happening here at the same time. But it's nothing to be scared of. For 42, we got Y equals 2X minus 3. You can see the question here. So my first step, I'm going to just swap the positions of X and Y. So X equals 2Y minus 3. Then we're going to try to get Y by itself. Before we can do that, we got to get the farther people moves first. Like the people who are farther away from Y has to move first. So we're going to move Y minus 3 by doing plus 3 on both sides. X plus 3 equals 2Y. Now, 2Y, 2 is a base of an exponent. So because it started as a base of an exponent, it's going to become a base of a log. So it's going to become log base 2. We're going to use parentheses because everything is going to go on top of this base. X plus 3, close parentheses, equals Y. Now the Y is normal size, and that matches what we have here. Okay? And just remember, the opposite ln is the letter E. So the opposite ln is letter E, or you could think of a ln is the same as log base E, okay? So I can move E first and then subtract by 1. I think that's for 4.4, and some reason I signed out, that's weird. Okay, so we're going to the next one, and my computer screen is freezing too, which is, you know, perfect on a live Zoom and all that. Okay, so let's go to the next one. Let me clear all this drawing. So we're going to go 4.5. Let's go to page 626. Expanding and condensing. A lot of people, even in like, I remember teaching accelerated, have problems with expanding, condensing. Our expansions and condensing will be at biggest 3 pieces, but they're still a little tough sometimes. So there's nothing to be ashamed of if you're having a hard time. So let's do some of these. So let's do 15, okay? So let me get this drawing. So let's do 15 real quick. When you have 2 things multiplied to each other on the inside of a log, when it spreads out, it's going to become addition. So this 4 times x becomes log base 3, 4 plus log base 3x. Let's do number 17 in the fullest form. So 17 is over here. So we got log 3x to the 4th power. So log 3x to the 4th power. So number 17 over here, 3 times x to the 4th is happening first. So let's take care of that. 3 times x to the 4th. Let's split that up, okay? Remember, that 4th power is only on the x. It's only on the x. So because they're multiplied, we're going to add the differences. So add log 3 plus log x to the 4th. Okay. All right. This 4 exponent, when you have an exponent inside a log, it can move in front. So then you're left with log 3 plus 4 log x. And that should be our final answer because there's no more to expand, like everything's been expanded. Now, I talked about multiplication. I talked about exponents. Let's talk about division. So if multiplication is addition, then division is going to be subtraction. So this ln, so I'm looking at number 20, ln 12 divided by 5, division is subtraction. So if it's divided together, you subtract separately. So it becomes ln 12 minus ln 5. And then let's do a one that's kind of like what I would consider the tough one on your test. Let's take number 23. This is probably like the toughest one you'll get on your test because there's a lot of things going on here. It takes a lot of space, but it's fine. So number 23, log base 7 of 5 times x to the third times y times z to the second. So you have 1, 2, 3, 4 terms going on at the same time. So when we write all this, we're going to write it as 4 separate terms. So we got log, and it's correct, you have to put base 7 because it started off base 7, 5 plus log base 7 x to the third plus log base 7 y plus log base 7 z to the second power. Okay, so first you want to separate all your multiplications to do additions, and if you had any divisions you would do subtractions. Okay, so I don't have to rewrite too much. I'm going to move this 3 to the front. I'm going to move this 2 to the front. So I'm just going to rewrite the things that change. So that should be 2 log base 2x log, I'm sorry, base 7. I'm sorry, base 7. Log base 7y stay the same. Plus, that's 2 log base 7z. So that's log base 2 7z. And that right there is our answer. And I think they show it, where's that, 23? Right here.
How many of the kinds like 23 are we gonna have? Are we gonna have more than one?
We're gonna probably have 2. Well, no, 2 or 3. So probably it would be like, if I'm thinking what I would do, 1 multiplication one, 1 division one, and 1 like combo one where you had like
right, like one, like only one, like 23 though.
Yeah.
I have a question.
Yeah, go ahead, Gabe.
For log 7x to the third power, why does it become 2 log 7x? Doesn't a 3 go in front?
Oh, it was a 3 this whole time. Good catch, Gabe. So it should be a 3 here. I just misread my own sloppy mouse handwriting. Good catch, Gabe, though. Okay. So expand, and then the opposite expand is about to happen, which is condense. Okay. Steiner, thank you for coming. I got you down. So you're
sorry that I wasn't here. I didn't know we had a Zoom.
That's fine. Here's the very important thing, though. On the test, which is Thursday, it's going to be live on Zoom. You got to make sure to come on time for that one. I'll put enough reminders. I'll remind and all that. You got to come on time. I'll post it 5 minutes early so you can print it out if you want to. And then you're going to take your test, and then you're going to take your phone, take a picture, and then submit it to Google Classroom within the time you take the test. So you're going to be doing it live on Zoom with everyone else, okay? So that's the important thing. You have to be here to take the test. You cannot take the test by yourself. It's not a take-home test. And I'm going to mark it like a test, so please, we're going to treat it like a test in that sense. All right, let's continue. So now we're going to condense. So let's just do a basic 2 here. When you subtract separately, you divide together. So it just becomes 7 over 10. You could only condense if they have the same log bases, but I'm not going to trick you in any sense. I just want to point that out. They only could condense if they're exactly the same logs, but in this case, they're all going to be the same logs. Like, they're not going to trick you like that. I'm not going to trick you like that, I should say. Let's look at, they don't have a basic adding one, but just like if you were adding, you would multiply it. But let's look at 35 real quick. there's a 2 in front of the log x. So when there's a 2 in front, we're going to do the reverse. When it was on top, we put it in front. Now it's in front, we're going to put it on top. So it's going to be log x squared plus log 11. From there, because there's a plus sign right here, we can multiply them together. So it ends up being log, and usually you want to put your constants, which are your normal numbers, first. So 11x squared. If you wrote x squared 11, you'll be fine. Okay? So when you condense, you're just doing the opposite. Let's do a relatively tough one. Let's see what's a tough one here. Number 38 would be something I would give you. Okay, so number 38. So everything that's in front, we want to move it on top first. So this 5 is going to go on top of this 2. This 7 is going to go on top of this x. This 4 is going to go on top of the y. So we got log base 4, 2 to the 5th power, plus log base 4, x to the 7th power, plus log base 4, y to the 4th power. Okay? From all of that, now they're all plus to each other, so now you could just condense them into one. This 2 to the 5th power, though, when you have a number that you're raising the power, I would like to see the actual number. So you're going to do 2 times 2 times 2 times 2 times 2, or 2 to the 5th power. That happens to be 32. So I'm going to rewrite this as this one at least, log base 4, 32, okay? So I'm going to rewrite that one only.
If we forgot to multiply it, would we get it wrong?
You know, I'd be honest, I probably would not mark you points off, but I would be like a little X. So I
Yeah,
don't think I would.
you'd like comment on it.
Yeah, I'll be like, you should multiply it out. So then either way, so this is 32. So now since they're plus, we could combine them. So we're going to make it all one log. So log base 4, 32 x to the 7, y to the 4. And I'm sorry, it looks like a little bit of a monster in the handwriting. Let me try and make it a little cleaner. But that's log base 4 in front. And then all those numbers, which matches what's over here anyway.
Can you just say one more time how you got log 432
Oh,
from
2 to the 5th power. So 2 times 2, which is 4, times
Right.
2, 8, times 2, 16, times 2, 32. So you could just do 2 to the 5th power on your calculator. Okay, so that's my expanding, that's my condensing. I believe that's all I did in 4.5. And then 4.6. Doing this all, I thought there was more to this, but seems to not be as much as I thought. So that's, I think that's a positive. So 271, 3 to 8. So funny enough, 271, I think is a little tougher because you actually, well, yeah, it's a little tougher, I guess. Nah, I don't know. You decide if it's tough or not. But 271, when they match, did any of these match? No, none of these match, but we talked about it before I started recording. I'm just going to do this for the recording. But if they match exactly the same, like if they match exactly the same, you could just cross this out and you could become a normal equation. But these questions don't match. So let's talk about what happens when they don't match. Okay? We're going to have to make a match. So let's take number 3, a very simple one. So that's 5, x minus 4 equals 25, x minus 6. Yeah. So this 25 and 5 don't match, and that's kind of an issue. I want them to match. So what I'm going to do is figure out how can I write the bigger one to match the smaller one. So I'm going to go 5 to the 1st power first. That gives me 5. Well, that doesn't really help me. 5 to the 2nd power equals 25. Oh, ding, 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 ding. That's what I need to see. That's what I need to see. So now, this one on the left stays exactly the same. So 5x minus 4. This one on the right, though, is going to become, this 25 becomes 5 to the second power. Because they're equal to each other, 5 to the second power equals 25, it's okay if I replace those numbers like that. Some of you guys said, like, oh, do you want to divide it? The thing is, dividing it actually changes how much it's worth. So we don't want to do that. So we just want to figure out a way to rewrite it equal to each other. So we have x minus 6 here. Now, here, this 2 power, the yellow is kind of hard to see, but the 2 power times the x minus 6, we can distribute this 2 to both the x and the negative 6. So on the left, still nothing happened to the left yet, so still x minus 4 here. But the right is going to be 5, 2x minus 2 times 6, 12. Now we finally, after all that work, made the 5s match. And because the 5s match, we could cross this out, and we could just do our normal algebra, which is, and I'm going to just type it, x minus 4 equals 2x minus 12. So from there, I could just do some algebra 1 skills. Minus x, let's get all the x's on one side. So that's a negative 4 equals x minus 12. And then plus 12, 8 equals x. And hey, that matches the answer in our textbook here, so that makes me feel good. These answers come out of fractions just because it's like 5 divided by 7. That's fine, just leave it as a fraction. I don't care if you change it to decimal or not, but sometimes there's going to be awkward numbers that divided. Don't worry if your answers become fractions. That can happen. But just leave it as a fraction. Don't do any magic to it. Okay? So that's solving when it's an exponent equation. We'll call that an exponent equation. Which is the main skill that you need is to be able to change your exponent, your base, into matching bases. Okay? And I would recommend I would like you to skip, and I'll change this on the sheet. Number 5, 6, I would cut those out. Because they do something differently, and I don't want you to bother with that. So cross out 5 and 6, and let me actually just change that. So skip 5 to 6. Okay? But those don't do those. I'm looking at them now. I wouldn't give you one like that, because then you have to reduce both of them. I don't want you to reduce both of them. Let's just reduce one of them. Okay. So we're near the end. Last one, I think, is these. Solve the log equations. Now we're going to do log equations. Now, log equations, what's really nice here is that they're always going to match. So log base 5 and log base 5, that's always going to match. So we're happy here. So when you could cross that out, then you could just rewrite it. If 5x plus 9 equals 6x, I could subtract 5x on both sides. I could subtract 5x on both sides. I get 9 equals x. So that's pretty simple, you know. So that's really nice. But we have to do something afterwards, which is called check for extraneous solutions. So it will say that in the instructions. So there's no question like, oh, what section do I use it on? It will say that in the instructions for that section. So check for extraneous solutions. How do we check for extraneous solutions? Well, the problem is we cannot have a negative value in a log. So what does that mean? If you have log 1, that's fine. If you have log 0, that's fine. If you have log -1, that is not okay. We're not allowed to have negatives in a log. And I explained that in detail in the YouTube video associated with this. But all you need to know is that you're not supposed to have your end result be a negative. So what we have to do is just plug it into either one of these. You don't have to plug it into both. Either one of these and see if it becomes negative. If it does become negative, that means it's not a solution. So for example, if I plug it into the right one here, if it's 6 times 9, that's 54. The question is important. Is that negative? No, that's not negative. So that checks off. So your answer is a real answer. So I'm going to do 27, which fails the test, let's say. So we have log base 5 equals log base 5 stuff. Again, the logs match. So because the logs match, I could cross them out. Makes my life a little easier. So I got 2x minus 7 equals 3x minus 9. Let's get all our x's to one side. So minus 2x minus 2x. So we got negative 7 equals x minus 9. And we're going to do plus 9 plus 9. So 2 equals x. So notice how my x is a positive. That doesn't matter. What I need to check is when I plug it in, is it positive? So I'm going to choose one of these. This has smaller numbers, so I'm going to choose this one. So 2, that x right here just becomes a 2. So this also is a 2. Minus 7. That's 4 minus 7. Well, 4 minus 7 is negative 3. As soon as you see that your final result is a negative, cross that out, cross that out. This is not a solution. 2 is not a solution. It causes let's call it an imaginary solution. It causes an imaginary solution. So because that is an imaginary solution, that's not a real solution. So you don't have any other x's here, so you're just left to say this, no solution. Be prepared for one of your questions on your test to be a no solution. Okay. Otherwise, I think that I did everything on the checklist. If you have any questions, I'm happy to re-go over any one of them.
Can you post a little bit more of inverse of function, like practice? 'Cause that's like
You want more practice problems of that?
Yeah.
Okay, I'm probably going to refer to an old worksheet if we have. I might have posted the old worksheet. I don't know if I have. But
So I did all the problems like on the page, but do you know if there's any other place we could find problems for inverse?
Sure. You said inverse? Finding
Yeah,
the inverse
inverse of
or
function.
using inverse? Because there's a technical.
Inverse of a function, the one that was like 37 through 44
Okay, yeah, sure.
on page 256.
Yeah, that's fine.
Yeah, that's the only one I need to practice.
Okay, I'll post that. No problem.
Sure.
Any other questions? You're free to leave if you don't want to, or you need to.
Thank you
Hey,
for
no
the
problem.
review.
Thank
Have a
you.
good day.
Thank you.
All right, see you around, guys. Have a wonderful day. I'll post this on YouTube so you can rewatch it.